Good day, grade 12 learners. Welcome to today's technical sciences lesson. My name is Musa Zulu, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Welcome back, grade 12. It's been a while. Last saw each other for term 3 as we're preparing for our prelim examination, which I'm hoping that people did well on. And if that was not the case, it's not too late. We can still work to it through this, and we can still make it during our final examination. Great job. Let's do this topic that we've looked at before, but now as a revision, and let's intensify our revision. Let's go over some of the most important things. And this topic here carries a lot of marks. And if you just grasp the nitty-gritties of these topics, there's small details, the small things that a lot of people lose marks on, then definitely you're going to be getting these marks that I want you to move with. And the topic for today is going to be mechanics. While we're doing mechanics, you know that mechanics carries a lot of marks. For our final examination, grade 12, mechanics carries a lot of marks. But the specific topic will be, we'll look at elasticity and hydraulics. As I've said here, grade 12, this topic here carries a lot of free marks. It has a lot of free marks. It just has small details that a lot of you tend to overlook, and then this is where a lot of people lose marks. But if we can grasp these details, and if I can show you which details are those and what to focus on when studying for this, then I'm definitely sure that when going to your final examination, you're going to be able to get those marks that I am looking for. So without wasting any time, let's go through our lesson. All right, what is our objectives? What is it that we want you to know by the end of this lesson? Well, by the end of this lesson, grade 12, we say you must be able to define at least the term strain. You must be able to define the term stress or stress and strain. And then you must be able to at least state Hooke's law. And then you must be able to then calculate. Okay, obviously, before we can go to the calculation, there are a lot of definitions that we are going to look at. But I've just decided to start with these ones to say, really make sure that you start with these ones. But there are a lot of definitions that are involved with these topics. Unfortunately, there's a very unfortunate, but one good thing about it is that you can grasp them. You can, if by now you haven't, I can promise you that you only need a day. You don't need like 2 days, 3 days, or the whole year to grasp these definitions. You can just need a day of focus just to say, after this lesson, I realize these are the definitions that I need to grasp. You go home, you sit down for all of this, the rest of the Friday. By the time you wake up tomorrow, you know these definitions and you'll be home and dry. All right, and then from there, we must be able, or you must be able to do calculations that are going to involve stress, strain, and the modulus of elasticity. And this is where our most of our free marks is going to be, where we are defining and we are doing these calculations. And this question, grade 12, I want or expect you to take all marks there, because there's nothing that can be so tricky that you won't be able to get those marks. Then also by the end of the lesson, I want you to be able to state Pascal's law, one of the law that is favored by the examiner. The examiner usually asks this law, and I want you to be able to take those 2 marks when the examiner asks the law. And then after being able to state Pascal's law, I want you to be able to use Pascal's law to do calculations that are going to involve force, right? Whether it be force 1 or force 2, you will see when we deal with it, but I'm sure by now you have an idea, because we're just doing a revision now. And then a calculation of a radius of pistons, and then it could also be calculation of areas, okay? Areas of those pistons. Either you're calculating the area of a piston, you're calculating the radius of the piston, you're calculating the force, okay? So these are some of the things that could be asked in relation to Pascal's law, okay? And then the calculation of areas and radiuses could also be taken back to stress, strain, and the modulus of elasticity, okay? But we'll see all of these things as we engage with our lesson, grade 12. All right. Pre-knowledge, what knowledge that we are expecting that you must be having as we dive into this revision. Very important. These are the nitty-gritties I was talking about, the grade 12, the small things that I'm saying that if you grasp these things, you are going to be fine. The conversions, it's the conversions, grade 12. You must be able to convert, especially from these units. especially, I'm not saying only these units, but especially from these units. People must be able to convert from millimeters to meters. They must be able to convert from centimeters again to meters. And you must always remember that we do calculations in SI units, okay? And the SI unit of distance of height will be meters, okay? The SI unit of distance, displacement, height, radiuses will be in meters. So anything that is not given in meters must be converted in or to meters. So most likely you are going to be given your distances, your heights, your radiuses. It will be given in either millimeters or centimeters, okay? If not meters already. So if it's already given in meters, then you are fine. No need for conversions. But if it is given in centimeters, then you must do those conversions, moving from centimeter to meter. If it is given in millimeters, you must do those conversions, moving in millimeters to meters. And you must know how to convert. These are the small things that I'm going to be emphasizing for today, to say, know the conversions. If you know the conversions, then you're going to be home and dry. A second small thing that I expect that you must come, because this is not part of the curriculum of technical sciences. It's actually part of the curriculum of maths, and it has been done in previous grades, okay? These conversions here, where you are converting from square millimeters. This is when you are converting area, because area in SI unit will be square meters, okay? The SI unit of area, SI unit of area is square meters. But now you can also be given square millimeters, a magnitude in square millimeters. It can also be given in square centimeters. Does this mean you take the number and you calculate with it as it is? No, that's not going to be the case, grade 12. You must convert from square millimeters to square meters. And you must convert from square centimeters to square meters as well. So here what I want to do, I want you to make it simple for you how to do those conversions. And I want you to use those conversions from moving today and towards your final examination. I have a feeling that the questions are going to be around this, okay? Right. And then lastly, I will expect that people, or I'm expecting that people are able to do calculations. Okay, they can at least remember or recall the formulas that are used for calculating what? The area of a circle, 1, the area of a rectangle, the area of a square. Those three basic shapes, okay? Because what we're going to be dealing with here are solids, solid material that are going to be having some shapes as their surface area. And these shapes are either going to be circular shapes, they are going to be rectangular shape, or they are going to be square shapes, okay? I do not think that you will find a triangular shape. I don't think you are going to encounter a triangular shape. But if it happens that you encounter a triangular shape, we'll talk about it a little bit, but I don't expect that one. What we have encountered before is a circle shape, and it's a rectangle shape, is a square shape. So these are the ones that we're going to prepare. These are the ones I'm going to say. With this preparation, you should be able to take all those marks after you have done, obviously, the necessary practice that is needed. Okay? Right. So, well, we have to ascertain whether you do have this knowledge that we are talking about by way of giving you a baseline assessment, of course, grade 12. So here's a baseline assessment that I'm going to expect that you are going to be answering as I'm reading here. Number 1, I want you to convert the following SI unit. I want to know, can you convert the SI unit 2,300 millimeters and 25 centimeters to SI unit, okay? The first thing that I want you to remember is when I talk SI unit from millimeters to meters, what is that? From millimeters, I mean, and centimeters, what is that? I need you to remember that the SI unit will be what? It will be meter, all right? So I need you to remember. So it means you are converting from 2,300 millimeters to meters. Or better yet, let's put it like this. If you see millimeters there, you must convert it to meters. Always, always, always. If you see centimeters, it must be converted to meters. Always, always, always. Okay, right. Now convert the following to square meters. Okay, so again, square millimeters must be converted to square meters. square centimeters must also be converted to square meters. And this is what we are expecting that you should be able to do. As I'm talking, I'm expecting that you are doing that as well. Then calculate the area of the following shapes: the area of a circle, the area of a rectangle, and a square there. Okay, what is it that I need you to remember just to help you there quickly without any waste of time? The formula to calculate the area of a circle will be pi r squared. Or for other people, they will say area is equals to pi d square over 4, right? Pi d square over 4, right? And then the area to calculate, or the formula to calculate the area of a rectangle will be A is equals to length times breadth, okay? If not, area is equals to length times width. Whichever one you decide to use, we are fine with, okay? And then lastly, the area, or the formula to calculate the area of a square, area is side square. Other people say area is length square. Again, whichever one you are most comfortable with. All right. So I hope by now you have quickly done those calculations, and you have shown to me that you do possess this knowledge. And if you don't, this is going to be the most important thing that you must make sure that you possess. Okay. So let's look at our solution and how we're supposed to do those conversions. So we are saying, let's convert them from 2,300 millimeters to meters. So the expectation is that you're going to say 2,300, and then you are going to multiply by 10 to the power of negative 3. That times 10 to the power of negative 3 by 10, 12, that is the conversion factor. Okay, so a lot of people are going to do 2,300 and divide it by 1,000. If you are comfortable with that, and it's fine, go ahead and use whatever you are comfortable with. But what you must make sure is that you know that you are dividing when you are going from millimeters to meters. So it's 2,300 divided by 1,000. And this is when a lot of people get that confusion of whether am I dividing or am I multiplying. For me, the easiest thing is to remember those SI prefix that we spoke of in grade 10, where we say milli is equivalent to times 10 to the power minus 3. So wherever you see milli, you say times 10 to the power minus 3. Wherever you say C centi, it's times 10 to the power minus 2. Wherever you see micro, times 10 to the power minus 6, and so on and so forth. I hope you remember those things. So if you have those things, it's going to be relatively easy for you, okay? Or remember those SI prefix. Okay, now let's say grade 12, you have a problem, you do not remember those SI prefix. It's fine. Let's try it like this now, going into the final exam. Just memorize that millimeters to meters is times 10 to the power minus 3. You don't have to go and look for all those other SI prefix, especially specifically for this topic, okay? I say to you, it would be millimeters, it will be centimeters, okay? Or it will be meters. So no millimeters, you convert it by saying times 10 to the power minus 3, and no centimeters, you convert it by times 10 to the power minus 2, okay? And then when you are converting that, it will give you, just press that in your calculator, it will give you your correct answer, okay? So I hope you understand what I'm talking about there. Here we had 2,300 millimeters. Now we multiply it by times 10 to the power minus 3. Now it will be converted to 2.3 meters. Hope you are with me there. Okay. Then we had 25 centimeters. Centi times 10 to the power minus 2. So it's 25 times 10 to the power minus 2. That will be 0.25 meters. These are the most important things in this topic. In this topic, grade 12. Be able to do these conversions. Don't forget to convert. Convert, convert, convert. Okay? All right. And then if we check the second question, it was asking us to convert to square meters. So we are converting the area now, okay? Because it is square millimeters, it is square centimeters. So to convert the area, you must remember that it was 7.5 millimeters squared, okay? So let's remember, to go from millimeter going to meters, you multiply by 10 to the power of minus 3, okay? Now to go from square meters, and you are going to square meters. So what are you basically doing here? You are squaring the millimeters, you will square the meters. So that means you must also square the conversion factor. As simple as that. So that will give you what? times 10 to the power of minus 6. Okay, I hope you are getting what I'm talking about, grade 12. If you don't understand this, then try to memorize it and say, to go from square millimeters to square meters, I multiply by 10 to the power of minus 6. All right? Okay, so that's why here you have 7.5 times 10 to the power minus 6. Okay, so by doing it like this, you have already converted it. You don't even need the ordinary value. You can leave it in scientific form in that way. Okay. All right, then the next one was 9.2 centimeter squared or square centimeters. So how do we deal with this one? Well, we have to convert from a centimeter to meter. Let's look at that one. We say times 10 to the power of minus 2, right? Okay, now we are going from centimeter squared to meter squared. What are we doing basically? We are squaring the centimeters to we are squaring the meters. So it means we must also square the conversion factor, which will leave us with times 10 to the power of minus 4. Simple as that. So to convert from square centimeters to square meters, you just multiply by 10 to the power minus 4, and you would have converted that way. All right. And then let's move on to the next question, which was calculate the area of the following shapes. I'm spending a lot of time here, grade 12, because when I said there are small things that you focus on that will make you to lose marks. These are the small things I was talking about. The conversions and the calculation of area. The conversions and the calculation of area. Most of us here are aware of the formula to calculate the stress, the strain, the modulus, elasticity. We are aware of these formulas. We can use these formulas. Our issue is when we have to deal with the question that needs us to do conversions, that needs us to calculate our area. That's where we mess it up. So let's focus here and make sure we get it right. Okay? What formulas are we supposed to be using when doing these calculations? Area is given by pi r squared, or area is given by pi d squared over 4, right? So we do know that the diameter there is 12. We do know that the diameter there is 12 meters here, right? Here it is given to us there as 12 meters. The diameter is 12 meters. And then with this formula, R stands for the what? The radius. R stands for the radius, grade 12. So we must remember that. And then D here stands for the what? The diameter. D stands for the diameter, all right? So what does that mean? It means if I am going to use this formula, I must get myself the radius, okay? And how do we know or get the radius? We remember the relationship between the radius and the diameter, all right? The radius is always the diameter over 2, or half of the diameter. Okay, so if our diameter was 12 over 2 gives us what? 6 meters. Luckily for us, it was already given in meters, so that means we don't need to convert it. Then we go straight to the formula, pi r squared. Pi 6 squared is how we substitute, and then we get our answer as 113.10 square meters. That's the area. Okay, we can also do this using the other way, where we are going to say pi d squared over 4. Pi d squared over 4, we are going to say, well, we substitute the diameter as it is in this case, 12 squared. So it's pi 12 squared, because d in this case stands for the what? The diameter. Or here it is. Had to go back, but it is right here in front of me. It is standing for the diameter, which is 12 meters. It's already in meters. No need for us to do conversions. Then we substitute it in the formula, put it in the calculator exactly as it is. You should get this answer, grade 12. And I hope you are moving with me. As you can see, the answers are the same. So these are two options of calculating the area. I'm aware that some people use this way and some people use this way. Stick to the one that you've been using and are comfortable with. But remember, if you use this way and you are given a diameter, you must always calculate for the radius by dividing the diameter by 2. Okay? If you use this way and you are given the radius, you must remember that you must always say the diameter is 2 times r, or 2 times the radius. Multiply your radius by 2 to get your diameter. Okay? So you must always remember that. Okay? If you remember that our radius was 6, so it's 2 times 6, that should give you 12 meters. I hope you are with me there. So remember those small details, small details that people lose marks on, because some of you would say here, instead of writing this 12, we don't know whether I should write 12 or 6. Okay, you always remember those small details. Grade 12. All right. Now that's one, and this one, grade 12, is the one that they like asking. They ask this one the most. So make sure start with this one. Start by the calculation of the area of a circle. Once you're comfortable with that one, let's move to the calculation of the area of a rectangle now. And here it is here, a rectangle of 9 centimeters times 4 centimeters. What's the formula? Length times breadth. This is the easiest one, okay? But the issue here is that the 9 is in centimeters and the 4 is also in centimeters. What does that mean? It means we must convert. We must convert from centimeters to meters. There is the conversion coming back, okay? And look at how I've written it. 9 times 10 to the power minus 2. That's me converting 9 centimeters to meters, okay? Right. Multiply by 4 times 10 to the power minus 2. Excuse me. That is me converting again from centimeters to meters. 4 into meters. That's the conversions that I'm doing. I put it in the calculator. It gives me 3.6 times 10 to the power minus 3 square meters. Okay? Because this is area. Then lastly, the calculation of the area of a square. All right? The calculation of the area of the square, I will say A is equals to S squared or L squared, whatever you use. But at the end of the day, the substitution would be the same. It will be 3 squared. And then you will get that the area of a square is 9 square meters. So these are the most important things to do, grade 12. Let's be able to convert between millimeters to meters, centimeters to meters, square millimeters to meters, square centimeters to meters squared, okay? And then also let us be able to do those area calculations for the 3 especially shapes, being the circle, the rectangle, and the square. Whenever we are encountering a question, the first thing that we are going to look for, do I have any conversions to do? And what shape am I dealing with? That is going to guide us in getting our area if the area is not given. Okay, right. So let's move on to our lesson, grade 12. Let's look at the terminology. What are we going to be looking at for today? So we're going to be looking at things like the deforming force. So we're going to be looking at mostly definitions for this terminology. Deforming force. And what is a deforming force? We say the deforming force will be a force which changes the shape and size of a body. And then we're also going to look at defining elasticity, the property of a body by virtue of which the body regains its original shape and size when a deforming force is removed. That's elasticity, okay? Right? We're talking about objects that are elastic. These are objects that are going to do what? They're going to regain their original shape and size when a deforming force is removed. You must also have some ideas of these objects, things like trampoline, things like elastic bands. Okay, so we must also think of these things. These are elastic objects. Okay, right? Have some examples of them ready, because they could easily ask you to state those examples. Right. Then perfectly elastic bodies. Okay. A body which regains its original shape and size completely when a deforming force is removed. Those that do it completely, they regain their original shape and size completely when a deforming force is removed. An elastic rubber band. You stretch it, what does it do? When you let go of the deforming force, or you remove the deforming force, it regains its original shape and size completely. Again, I've talked of a trampoline. As you jump on a trampoline, you are a deforming force as it goes down, and then while you are up there, it goes back and regains its original shape and size. That's when you are removed as a deforming force yourself. Perfectly plastic bodies, a body which does not show a tendency to regain its original shape and size when a deforming force is removed. Such bodies as clay, okay? Such bodies as putty, okay? The putty that is used to balance windows there, right? Post-it, I always think of that. You are pressing that putty, it just deforms, okay? It does not regain its original shape and size. So it's a perfectly plastic body. We say those bodies are plastic, okay? We're not necessarily talking plastic, the synthetic material, but we're talking plastic in the form that it does not show a tendency to regain its original shape and size when a deforming force is removed there, grade 12. Okay, so as we move, we can also talk of elastic limit. This is the maximum force that can be applied to a body so that the body regains its original shape and size completely on the removal of a deforming force. Okay, so if a deforming force is removed and then the object used to regain its original shape and size, but now it does not, it means it has reached its elastic limit. Okay, that's the maximum force. Hooke's law: within the limit of elasticity, stress is directly proportional to strain. We must be able to state that. We're going to talk about that also as we look at the elasticity of modulus, right? Or modulus of elasticity. Stress: the internal restoring force per unit area of a body. We must be able to do that definition as well. Strain: the ratio of change in dimension to the original dimension. And then thrust: the normal force exerted by a liquid at rest on a given surface in contact with it, right? As we go, pressure: thrust acting on the unit area around a point. And then lastly, Pascal's law: in a continuous liquid at equilibrium, the pressure applied at a point is transmitted equally to the other parts of the liquid. Now, grade 12, let's not panic, all right? No panic. Let us not panic here, grade 12. Let us not panic. I know that I've listed a lot of definitions that I say you need to know. And I'm not even going to say, now know these ones. These ones are the most important, because when it comes to the examiner and this topic and the definitions of this topic, the examiner always chooses whatever he feels like. I will tell you that maybe out of all of these definitions that I've listed, maybe 4 are going to be asked throughout the whole paper. 4, 3 maybe, okay? Even 2 can be asked throughout the whole paper, and even 1 can be asked, all right? But I doubt it will be more than 4. But if you know all 4 of those ones that are asked, there is 8 marks that is free to you. So I will say to you, go home and make sure that you go over this definition. The definitions that I've given to you are according to the exam guideline. They are according to the exam guideline. So I know that if you state them like this, you are going to get your 2 marks, because when it comes to definition, it's always 2 marks or nothing. So just go home and memorize or work on these definitions. I promise you that you only need a day. Need a day, and tomorrow you test yourself on them. Sunday you rest, Monday you test yourself on them. By Tuesday, I promise you, you'll be knowing all these definitions. You are guaranteed those marks. And I'm telling you, they will be asked, one of them. Unfortunately, I don't know which one will be asked. Okay, right. So let's dive into the summary of this lesson, the most important thing. Grade 12, we want you to be able to do what? To understand stress, of course, right? And strain, and then understand the elasticity of modulus or Young's modulus there. But most importantly, the calculations that we are going to be working with. It's a revision. We are focusing on what is going to be asked on the exam. So I'm going to be focusing on the calculation and say, these are the calculations that I need you to make sure that you know, right? But firstly, the definition of stress. The internal restoring forces per unit area of a body. So while we were doing, or when we were learning this for the first time, we talked about that if there is a deforming force, there are internal forces that are going to develop inside the solid material, and these internal forces, as they develop, they are going to what? Be working against the deforming force. Okay, so and they are called stress. Okay, I even made some examples of how old people are saying they are stressed. This is how they feel and all of those things. Okay, so I need you to be able to define stress, grade 12. After being able to define stress, I need you to be able to do what? To do calculations that are related to what? To stress. So what calculations are going to be these? They are going to give you a scenario where they are asked you to calculate the stress. The stress can be compressive, by the way, all right? Where the deforming force is when we are pushing down on something, okay? Or the stress can be tensile, okay? A tensile can be tensile stress, of course, as well, okay? So where we are pulling or stretching something, so you must remember that. But they can always ask you to calculate that stress, whether it's compressive or tensile. The manner in which you do the calculation will remain the same, all right? And then they can always ask you to calculate the force the force, if they happen to give you the stress, it's possible. You'll see one of our examples there. So it's possible that they will give you the stress and ask you to calculate the force that was exerted to cause the stress. And lastly, they can always ask you to calculate the area, right? The area on which the force was exerted to end up causing a certain amount of stress. So these are the three that you should be able to know and work out with. So the first thing is being able to choose this formula correctly. So you must be able to see this formula in your formula sheet there, and then you must be able to write it down correctly. Now let's talk about writing this formula down. Great job. Right? I understand this symbol here is not an easy symbol to write. Okay? So, but let's not rush while writing this symbol. So this symbol is written like this. Great job. Okay? You write this symbol like this. Is equals to force over area. What you don't do is do this. Okay? Let us run out. Let's shy away from doing this, because what this ends up causing, it causes some of you to do this. Right? Now, instead of writing sigma as a symbol, you are writing S. And this is incorrect. Okay? Some of you do this. Right? As if you are now writing an integration symbol. Right? This is not, we're not integrating here. Right? We're talking sigma stress. So this, let's do away with this, because this is going to cause an incomplete formula as we mark you. And if we mark an incomplete formula, we mark it incorrect. We're going to say, this is not sigma. So please try to just take your time with it and write it like this. No one is going to write it like the computer, of course, like it has been written here, but just try to make sure that it looks something like a sigma symbol. Okay? So that's one thing I wanted to say about this. Okay, now we are able to write that. We can identify the formula for stress. We can do, maybe we'll then try doing the calculations. Now, before we move on to the next one, let's talk about the SI unit. What SI unit should we need or should we use for stress? After calculating the stress, the SI unit for stress will then be what? It should be Pascals, right? We've spoken about this. Either you use Pascal or you use Newton per square meter. So it's either you use Pascal or you use Newton per square meter. You choose one, don't write both. Okay, please don't write all like myself. If you are a person that has been using Pascal throughout the whole year, stick to Pascals. If you've been using Newton per square meter throughout the whole year, stick to that and avoid making mistakes. Okay, don't say just because now I'm using Pascals, you're now going to follow me. No. Stick to what you've been doing. Just make sure that you enhance it and make sure that it becomes better. Okay, so stick to what you have been doing. I do not do both. Right. So that will be stress. All right. So we will also take an example as to calculation of stress. Number 2, strain. The ratio of change in dimension to the original dimension. Easy marks, and people are making some small mistakes that we are going to allude and talk about here. Right. So strain, the formula here is the formula here with E is equals to change in length over original length. The ratio of change in dimension, which will be length in this case, to the original dimension, which will be the original length. Okay? You must be able to identify the formula as we have spoken, and you must be able to write the formula as it is. This one is very simple. We don't have to talk too much about it. And then we say, what about the SI unit? What is the SI unit of strain? The SI unit of strain is that there is no SI unit. Keep that in mind. We do not have an SI unit for what? For strain. And as we do not have an SI unit for strain here, if you happen to come up with an SI unit yourself that comes from anywhere, it comes from grade 12, we will definitely take the marks away from you. So we penalize if there is an SI unit. So here an SI unit appearing and someone is claiming they are calculating strain. So please remember that there is no SI unit, because this is the ratio of the same dimensions. Okay, so it's the same or same physical quantity. Let me put it like that. That will be the correct. It's a ratio of length to length. So it will be a ratio of meters to meters. They're going to cancel each other and leave you with 1. All right. So that will be strain. Then after strain, we'll talk about Young's modulus or the modulus of elasticity. Okay. All right. Now the formula that I have here has a symbol that is not incorrect, but it's a symbol that actually we don't use in technical sciences. Okay. So in technical sciences, we use the symbol K. So you will fix that for me, but you will find that in your actual formula sheet, you'll see it. The symbol that we use in technical sciences is K, but these symbols can also be used. It's E sometimes, it's K sometimes, it's Y sometimes for other people, but there are actual conditions as to why, which I won't go into details, is that which one is which and what are the conditions for using this one. And we're going to say K and we'll agree on K because we've been using K. So what's the formula? The formula is simple: stress over the what? Over the strain. The same stress that you calculated here, the same strain that you calculated here, you then simply take the values, the stress over the strain, and then you get your what? Your answer. What will be the SI unit of Young's modulus or the modulus of elasticity? The SI unit in this case will still be what? Pascals or Newton per square meter. How come? Because the SI unit of stress is Pascal and the SI unit of strain is 1, no SI unit at all. So it remains, this SI unit does not get disturbed. It's like Pascals divided by 1 remains Pascals that way. All right? Right. So this is what I want you to know around these solid objects that are going to be coming to you. Right? Calculation of stress, calculation of strain, and the calculation of what? Of the modulus of elasticity. Right? Okay. Right. When we talk of the modulus of elasticity, we have to look at Hooke's law, okay? Because the modulus of elasticity talks about the stiffness of the object. How much does it resist to be either stretched or compressed? How much does it resist the stress or to be strained, to be strained when it is experiencing stress, okay? So that can be represented easily using Hooke's law and in a form of this graph here, grade 12. So we say Hooke's law says what? Says within the limit of elasticity, stress is directly proportional to strain. So what do we say? We say we're having solid objects here that we are going to exert deforming forces on. And as we exert those deforming forces on this solid object, this object will change shape. It will be strained, okay? It will either lengthen or it will shorten, okay? So then Hooke's law talks about this based on the object's modulus of elasticity, right? On how much does it resist. Based on that, each object, each solid object will have its limit of elasticity. So it will reach a certain point where you have stretched it so much that it will no longer regain its original shape and size. It might even reach a point where it's going to completely do what? Break. Okay? So that relationship can be represented as a form of a what? A graph, a Hooke's law graph, where it shows that each object will have its elastic limit. And during this elastic limit, or before, sorry, not during, but before this elastic limit, it is said that the stress experienced by the object will be directly proportional to the what? To the strain experienced by the object. So within the limit of elasticity, the stress is directly proportional to the strain. Here is within the limit of elasticity, okay? Here is within the limit of elasticity, okay? Here is where we are at the limit of proportionality, where it is directly proportional. Here it is directly proportional, and after that it reaches a point where it's no longer proportional. That is when it's no longer regaining its original shape and size completely. So it's no longer a perfectly elastic body, as you remember those definitions that we are looking at. And if you go beyond the elastic limit, you would reach a certain point called the what? The breaking point. The breaking point. So here the object is actually going to break. You've stretched it enough such that it does what? It breaks. Or you've compressed it enough such that it does what? It is going to break. So you must be familiar with this representation, and you must be able to what? To interpret this representation given to you, okay? The gradient of this representation, because in this case it is given as force. What is force going to cause? Force is going to cause stress. So we can also represent it as stress, and this is extension. And extension can be looked at as what? As strain. So let's look at this representation as stress versus strain, right? And we are going to look at the gradient of this. The gradient of this, the gradient of any line will be given by the change in y values over the change in x values, okay? What are the change in y values? that is stress. The symbol of stress is sigma like this. And what are the change in x values? That is strain. And if we go back here, what is stress over strain? We're saying it is the what? It is the modulus of elasticity. It is the modulus of elasticity there, grade 12. All right, sorry about that. The modulus of elasticity tells you how much the object resists to be stretched or to be what? To be strained. So the gradient of this representation of Hooke's law representation of this graph, the stress versus the strain, is always going to give you Young's modulus. Hence, that's why I said they relate. So what is it that I want from you? I want you to be able to state Hooke's law. Of course, stating it is very, very important. And I want you to just be able to interpret this as these questions they like asking, especially there by the multiple choice questions. Okay, right. Now, let's go into example. Let's take an example and let's look at what I'm talking about here, grade 12. Right, here's the question. It says a mass piece of an unknown mass in capital letters, very important, magnitude, causes a stress of 10 Pascals. So we are given a stress, all right, in an elastic spring with an area of 0.01 square meters. What's the nice thing about this given value? It's already given in square meters. So if it's already given in square meters, it means I don't need to do conversions on it. I'm lucky there. The original length of the spring is 10 centimeters. Now this one is given in 10 centimeters. I might need to do conversions if I use that value there. The mass piece causes the spring to increase to 15 centimeters. Right, as you can see in the diagram here, it was 10 centimeters and then it increases to what? To 15 centimeters there, grade 12. Okay, so let's look at the question. The questions are saying state Hooke's law in weights, and we are saying here within the limit of elasticity, stress is directly proportional to the strain, and you stated that to get your 2 marks. And then it says distinguish between stress and strain. What is stress? Internal restoring force per unit area of a body is stress. And then strain is the ratio of the change in dimension to the original dimension. Simple as that. You have stated. How many marks are we getting here? 2 plus 4, that's 6 marks based on definitions alone. This is what I was talking about today, grade 12. This is what I was talking about. You see, these 3 definitions have been asked here. 3 definitions, because here they say distinguish. The only way you're going to distinguish is by stating those definitions. 3 have been asked and 6 marks for free. Right. 5.3, now they do the calculations that I was talking about. Now let's talk about collecting all marks here. Let's not talk about making mistakes here. Collection of all the marks. Calculate the mass that causes the spring to stretch. How do you calculate the mass that causes the spring to stretch? You have to think about it, okay? What are these people looking for? What am I giving? I am giving stress. What am I giving? I am giving area. What does the mass have to do with this thing? What is pulling this spring down is the weight of this object. It is the weight of this mass piece. And weight has something to do with mass. It's the product of the mass and the gravitational acceleration. So with that idea, I can go through the calculation and actually calculate and be able to calculate the mass. And how can I do that? I can simply start by saying, let's calculate the what? The force first, because I am given the stress. So stress is equal to force over the area there. Okay, right. Okay, what is my stress? I am being told that the stress is 10 Pascals. Force, I don't know that. Do I know the area? I do as 0.01 square meters. No need for me to do any conversions here because it is given to me. Okay, and then from there, I can just simply do cross multiplication. The force will be equal to what? Take my calculator. It will be 10 multiplied by 0.01. So my force will be equal to what? My 10 multiplied by 0.01 there. I get that it is equal to 0.1 newtons. So the force, which is the weight of this mass piece, is 0.1 newtons. Right? Now that I have the force, I now need the what? the mass. And how can I relate the force to the mass? This force is the weight. So I can always say W is equals to mg. What is my force? It's 0.1. The mass I don't know. G will always be 9.8 meters per second squared on Earth in terms of calculations, obviously, for us, right? 9.8 divided by 9.8, you get that your mass will be equals to what? 0.1 divided by 9.8 going into your calculator, you get that it goes back to 0.01 kilograms. We have the mass, 4 marks. Anything that was difficult here, we identified the formula that we need to use as the formula for what? For stress. After identifying that, we went and substituted, worked out the force, then from the force worked out the mass. And this question that I've just done here is the most difficult question they can ask when it comes to stress. One way you are calculating the mass. Anything from here is just simple. You are dealing with the formula for stress only. All right. Next question, calculate the strain in the spring caused by the mass piece. The strain will be calculated using the formula. Strain is the change in length over the original length. Okay, what is our change in length? Do we have our change in length in this case? Now here is where you have to be careful, grade 12. Here they said the length goes from 10 centimeter to 15 centimeter. You are not given the change in length. You are given where the length goes from to. So it means you have to get your own change in length, grade 12. So you must be careful. If they were giving you the change in length, they were going to use words such as it stretches by. Okay, right? It stretches by, it changes by. These are the words they could have used, especially that by is very, very important. This is the way that you must look for to tell that I have been given the change in length. But if they say it goes to, stretches to, they have not given you the change in length. They have actually given you where it goes from to. What you will notice is that when they use the word to, the next number will be bigger than the original number most of the time, obviously, especially if it's tensile stress, which I think is what they are going to ask most of the time. All right. So it means in this case, we have to do length final minus length initial over original length. All right. And then I'll continue here, which will be equals to 15, right, times 10 to the power minus 2, because centimeter to meters, I'm converting, minus 10 times 10 to the power minus 2. That's me already converting from centimeter to meters, grade 12, okay? Over the original 10 times 10 to the power minus 2. And then I should get my answer there, right? Now, I will tell you this, grade 10, 12, right? You have an option here. Since this is a ratio, the answer is 0.5 and there is no SI unit, by the way. No, you have an option here. Since this is just a ratio, you can decide not to do the conversion. But as long as all the units from the original to the final are the same, since both of them are centimeters, I could have just said 15 minus 10 over 10. As you can see, this 10 will cancel this other 10 here mathematically. But I would say if you are not sure of that information, you don't know that, don't do it. Always convert like I've done. That's safe for me. I always do that. Last question, calculate the modulus of elasticity. And the modulus of elasticity will be the stress over the what? The strain. Okay. So as I'm running out of space here, I'll calculate it here. It says K is equals to the stress over the what? The strain. And we know that our stress was given as 10. And we just found out that our strain is 0.5. So the modulus of elasticity should be 10 over 0.5. And we get our answer as 20 pascals or 20 Newton per square meter. Whichever one you choose or whichever one you use. Okay, right. So here are just some of the solutions. We have stated Hooke's law here. So as you can see here, right, without wasting time, we've talked about here stress, internal restoring force per unit area of a body, and then strain, the ratio of change in dimension to the original dimension. All right, that's the one that we are getting from the examination guideline there. All right, calculations, we've done the calculations. As you see, we started with the formula for stress. And then from there, we substituted here until we got our force as what? 0.1. They've already represented this force as the force of gravity. We represented it as F. It's fine. It does not change anything. And then here we substitute that 0.1 here, and then the 9.8, and we calculated our mass as 0.01 kilograms. We've done this and we got it correct. All right. From there, we went for the strain. This is just another option. We went for the strain, where we say strain is the change in length to the original length. Here we go. And then we remember that here we are not given the change in length, so we need to do the subtraction of final minus initial, and we did the conversion part. But as you can see in this option, you can do it without converting, as long as the units are the same. But again, I stress this, please, please, please do not use this method if you are not sure of yourself, okay? Just stick to, if you see something that needs to be converted, you convert it. Then from there, you calculate the strain as 0.5 without any SI unit. And then we go for the modulus of elasticity there. As you can see here, the symbol is what? Is K. Told you the symbol that we use in technical science is just what? Is K. So we stick to K. Stress over strain, and our stress was 10 pascals. Where is it? Okay, it is here. It was 10 pascals. And our strain, we calculated as 0.5. And we get what? 20 Newton per square meter, or 20 pascals. Okay. Now that will be an example of how you can gather those marks grade 12. As I'm saying, these marks, you need to make sure that you get all of them. We have taken all of those marks. How many were they? The marks, okay, right? These marks were 4, 8, 11 marks, right? 11 marks plus this 6 gives you 17 marks. 17 marks for free there, grade 12, all right? So, right? These are the solutions, and then we've spoken about those solutions there, right? So now it's your time. I'm going to give you 4 minutes, right, to just try this activity, and we'll see after 4 minutes if you are able to do the activity correctly. Grade 12, your 4 minutes starts now. Welcome back, grade 12. Right? I know that 4 minutes might have not been enough, but we do not want to waste time. I hope you were able to just try and rush through the activity quickly. If you're not done while I'm going through the first, the second, you are finishing off the last ones, okay? Try to do it like that, okay? But while you're trying to pay attention at the same time, I know you can do it. All right, so the question goes like this. It says a force of 16 Newton is applied to a 3-meter long metal wire. All right, so we have 16 newtons, and then we have 3-meter long wire, metal wire. Okay, the wire stretches by. I want you to take note of this word here. The wire stretches by. This word is the word that usually is used to indicate the change. You see, they're saying by. It does not stretch to. The wire was 3 meters. It stretches by. It does not stretches to. Okay. And as you can see, the number that it stretches by is smaller than the original number. So already in your head, you say, I have been given the change in length in this case, okay? I have been given the change in length. I don't need to do the final minus length initial. So I need you to have that difference, grade 12. Sometimes they give you the change in length, which is most of the time, but sometimes they expect you to calculate like we've done in the previous example. If they want you to calculate, they will say it changes to, and usually that number will be bigger than the previous number if it was the tensile stress or stretching, okay? If it was a compressive stress, obviously it will be smaller than the original number, okay? I hope you understand what I'm saying. Small details that makes people to lose marks. And then now they say the diameter of the metal wire is 2.5 millimeters. Again, this one is in millimeters and this one is also in millimeters. What does this mean? We have to convert, okay? And here you do not have that option where you say I can choose not to convert because it's strain. No, you have to convert because you see here the units are not the same. One is meters, the other one is millimeters. So you only choose not to convert if the units were the same. But if the units are not the same, you have to convert one of them at least. Okay? Now, with that being said, let's look at what they are asking us to do. They're saying we must calculate stress in the wire. And then, for us to calculate stress, we must remember that the stress formula is stress is the force over the area. So what do we need? We need force, we need area. Let's go back to our statement. Do we have force? Yes, we do. 16 newtons. But do we have area anywhere here? No, we don't. All right? So now, the next thing that we are going to be thinking of, right, okay, we need to calculate our area. So what shape are we talking about? It will either be a circular shape, a rectangular shape, a square shape, maybe a triangular shape. This one, let's count it out. Circular shape, a rectangular shape, and a square shape. So what shape are we dealing with here? It's a circular shape. How do we know? They spoke of a diameter. That's the first thing you do. Identify that. Have you identified that? Yes. Now I need to calculate the area. And how am I going to do that? Well, I am given the diameter. I'm going to say it is what? Area is pi r squared. This one is my favorite one. I always use pi r squared. If you are going to use pi d squared over 4, you're fine. And you are even better than me because you are quickly going to just use without doing the converting from diameter to radius. I, on the other hand, have to say the radius is the diameter over the 2 over 2. And what is my diameter? It's 2.5 divided by 2. I have to do all of that. I have to go through all that admin because of the formula I have chosen. 2.5 divided by 2 is actually 1.25. But that 1.25 is in millimeter. So I have to convert it by saying times 10 to the power of what? Minus 3. I have converted. Once I've done that, I am done. Now I can go and say pi multiplied by 1.25 times 10 to the power minus 3. But do not forget the what? The square as it comes with the formula. And I will quickly put it in the calculator and say pi multiplied by 1.25 times 10 to the power of a negative 3. Then you have to square all of that. You get that your area is 4.91. I'll say not 91, I'll round it off. 4.91. Oh, sorry, it's not the final answer. You round off before the final answer. 4.9087 times 10 to the power minus 6 square meters. You do not round off before you get to the final answer. So usually take 4 numbers after the the comma if you are going to do the calculations separately, right? Then from here, we can now substitute. We now have our area to calculate the stress. So our force is 16 newtons and our area is 4.9087 times 10 to the power minus 6. And what will be our stress? And usually it's going to be big numbers that we are going to be getting there. 4.90087 times 10 to the power of a negative 6. That should be a huge number as I expected. 325,951.81 pascals is our stress, the answer that we are looking for. Now, sometimes these numbers can be written in scientific notation. Advice to you, grade 12, don't write your answer in scientific notation. Get it, write it exactly as you see it in your calculator. We will accept it when we mark. Please stick to that, okay? Please, let's not do scientific notations, okay? All right, then strain in the wire. The strain in the wire will be calculated using strain is equals to change in length over the original length, which is going to be equals to, what's our change in length? It is 0.5 times 10 to the power minus 3. What's the times 10 to the power minus 3 coming from? The conversion from millimeters to meters. Small details that I've talked about. These are the things where people lose marks, grade 12. Don't forget to do that conversion over 3, okay? I have to convert in this case. I can't use that method of saying I can choose whether to convert or not. No, in this case I have to convert. I'm repeating because the units are not the same. For those who are aware of that, 0.5 times 10 to the power of negative 3. It's my change in length because the statement said it changes by this, all right? Okay, over the original length, which is 3, over the original length, which is 3. No, it's times 10 to the power of a negative 3. What are you doing now? Right, then it should be 1.67 times 10 to the power of negative 4 without any SI unit. It's strain after all. Lastly, Young's modulus. Look at the marks. 4, 7, 10. 10 free marks that we're talking about. Young's modulus will be K is equals to stress over the strain. Okay, this is K, right? What is our stress? 325,951.81 over 1.67 times 10 to the power of negative 4. And then we should get our strain as 325,951.81 over 1.67 times 10 to the power of a negative 4. And what are we getting there? We are getting 1.95 times 10 to the power of 10 pascals. Because like the stress, the SI unit of Young's modulus is pascals. So this is what I expected you to do, and this is how I expected you to answer these questions grade 12, right? I hope you were able to get these marks. Now, grade 12, before I move on to hydraulics, and before we run out of time here, I want to stress the issue, or before let's look at our solutions. Here are our solutions here, and as we did calculate it here, it is 3.26 times 10 to the power 6. It is written in scientific notation, but trust me, the answer is the same as the one that we got, okay? It is just written in scientific notation here. All right, in the marking guidelines, they like writing it in scientific notation. I always advise against it for those because I know once you make a mistake here, we have to penalize you. So please, okay, if your calculator gives you in scientific notation, fine, write it in scientific notation. But if your calculator gives you in ordinary values, then you have to write it in those ordinary values that you find it in, okay? Please, right. And these are just all the options that you can use to calculate the stress, obviously, right? And then the strain, here's our strain here, which is 1.66 times 10 to the power of minus 4, or 1.67, because we have to round off to 2 decimal places. And I want you to just take note of this here in the marking guideline grade 12. It says, note, penalize if the unit is given, right? It is telling you that we must penalize you if you decide to give us a unit while calculating strain. You must be penalized for that. So please, do not give us units. And then lastly, for the calculation of what? of Young's modulus, the formula here with the symbol K, and then it's the stress, and then the strain, the substitution, and then you get your answer here. Okay, right. So please, grade 12, attempt these questions. Please do not leave these questions unattempted. Please, grade 12, just go over the weekend and just spend time with this section here. This section can give you a lot of marks, as this section is always giving a lot of marks in the exam. Right. Now, before I move from the elasticity to hydraulics here and pressure and all of those things, I have to talk about the conversion of bigger values, because I've talked about the conversion of milli, and I said this is times 10 to the power of minus 3. I've talked about centi, and I said this is times 10 to the power of minus 2. And mostly these are the ones that I need for this section, okay? So here are the ones that I also need for this section that can come to you, right? People, please, kilo, right? Times 10 to the power of what? Of 3. If they give you your force in kilonewtons, just know that you must multiply that value by 10 to the power of 3 to convert it, okay? Please, 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 right? 16 kilonewtons. That means when you are going to write it as 16 times 10 to the power of 3 or 16 times 1,000, okay? Please, okay? Then from kilo, you go to mega, right? Mega is times 10 to the power of 6. And then from mega, you go to giga. Giga is times 10 to the power 9. And lastly, you are going to go to tera. And tera is times 10 to the power of 12. Please, I will always stress this. We always stress this. They can give you, because when we're dealing with stress, strain, and modulus of elasticity, we are usually dealing with large forces, okay? So they can give you these forces in mega newtons. They can give you even the stress in megapascals, kilopascals, gigapascals, terapascals. So you must know how to convert those values. Small things, the way you are losing marks, the conversions, okay? Converting from one unit to another, grade 12, please, right? Okay, so that's it when it comes to elasticity. It's the definition, it's knowing how to do calculations relating to stress, okay? It's knowing how to do calculations relating to strain, and it's knowing how to do calculations relating to what? To the modulus of elasticity. And also knowing Hooke's law, of course, and just interpreting that Hooke's law graph, and maybe some explanations will be needed. But for the focus of getting those marks, please, that's where I want you to start focusing. Please go over this again and try to do some of these activities on your own and see if you can do it, okay? Right, hydraulics. Now, when we talk of hydraulics here, we are talking of study of mechanical properties of liquids. That's where we are actually at, okay? Right, then what we need to know is this definition here, which most of the time is overlooked, but the examiner sometimes can just throw it there, the thrust, okay? Because when we talk of hydraulics, we have to talk of pressure. And before we talk of pressure, we have to talk of thrust, okay? Now, thrust is the normal force. It is a normal force. Why it is a normal force? Because it is usually, not usually, it's perpendicular. It's always going to be perpendicular. But it's a type of a normal force. It's a normal force that is exerted by a liquid at rest on a given surface in contact with it, okay? So it's a force that is exerted by a liquid at rest on a liquid, okay, on a given surface, I mean that is in contact with it. It is called thrust. And from thrust, what you get is pressure. So pressure is thrust acting on a unit area around a point. So when you talk thrust, pressure, it is thrust, right, acting on a unit area around a point. So these, I'm adding the definitions that you need to know and be aware of the grade 12, all right? So we're going to take two different types of pressures, or we're going to place it as if there are two different types of pressures, or that I need you to be able to calculate. One is called fluid pressure or liquid pressure. Liquid pressure, or pressure of liquids, okay? Pressure in when you are in liquids. How do I calculate the pressure in liquid? Okay, you are going to need three things. You will need to know the density of the liquid, which is going to be usually water, but they are going to give you, this will be given if you are expected to calculate. And then gravitational acceleration, which is always 9.8 meters per second squared. And then you need the height, obviously the depth, okay? The depth of the liquid, how deep it is. And the depth of the liquid will always determine the pressure. The deeper you are in that specific liquid, the more pressure you are going to experience. Okay, so that's pressure of liquids. Okay, you would remember that this was asked in June examination, where they asked you to calculate the difference in pressures from this point to another point there. This is the formula that you were just simply supposed to use there, grade 12. So I'm just running by that, one of the easiest things to do. But there's also just pressure, which is force over the area. All pressure is actually force over the area. Even this comes from here, right? But this is just has been simplified more. So it's specifically for liquids, this one. But this one is pressure specifically just in general. Pressure in general is force over the area. Okay. So, and the unit for pressure is pascals, as is shown here. The SI unit is pascals or Newton per square meters, as we're spoken about. So when you are asked to calculate pressure, these are the formulas that I want you to quickly go through. See if I can use this formula. If not, then can I use this formula? Are we together? Depending on what you are given. I hope you are with me there, grade 12. Right. But let's dive deep into actual hydraulics there. Right. So in hydraulics, we use the idea of pressure, right, in combination with Pascal's law. What does Pascal's law state? Pascal's law is in a continuous liquid at equilibrium, right? So we're talking about a continuous liquid at equilibrium. The pressure applied at a point is transmitted equally to the other parts of the liquid. So we're not going to waste a lot of time here. We're going to say, when we're dealing with hydraulics, we are going to be looking at something that looks like this, where we are going to be talking two pistons, okay? We're going to be talking two pistons with different areas, all right? Piston 1 will usually have a smaller area, all right? Will usually have a smaller area. And on piston 1, that's where we are going to exert even a smaller force. So the idea around the Pascal's law is that we are going to create a machine that is going to allow us to exert a small force, but it will produce a greater force for us, right? I hope you are thinking of things that can do that, right? So if we are thinking of things that can do that, imagine a person, small person that cannot stop a truck while they are outside the truck. It's moving. A person cannot simply stop a truck by their hands, right? But if they're inside, through the pistons, they can press that brake pedal that can actually put a whole truck to a stop. How? They exert a small force with only their foot, and that foot through those pistons and through the liquid that will be going there, or the fluid that will be going there, it will produce a greater force that will be enough to stop a truck. And that only happens through Pascal's law, the idea that in a continuous liquid at equilibrium, the pressure applied at the point will be transmitted equally to the other parts. So we have piston 1. This is where we have a smaller area. This is where we apply a smaller force. But the pressure that will come as a result of a smaller force applied here will be equal to the pressure that will be here. So P1 will always be equal to P2. If the pressure here was 70 pascals, the pressure here will also be 70 pascals, grade 12, okay? The pressure is the same everywhere, right? Okay, this side, this is what? Piston 2. Piston 2 is the one that produces a greater, or has a greater area first. Then will also produce a greater force. So piston 2 has a greater area and is going to produce a greater force. That's what piston 2 does. And now, as you look at this formula that we are talking about here, right? It starts from the fact that P1 will always be equal to P2. And we've already said that pressure is given by the formula F over area. Okay, so that means it will be F1 over A1 on one side, and then equals to F2 over A2 on the other piston. So they must be equal. Now, this is just another way of writing this formula, and I want you to ignore it. Well, don't ignore it, know it, but please do not use it, grade 12, all right?
you can know different ways of writing this formula because they can be asked in a multiple choice question. I've seen them asked before, so you know how to play with this formula where it can be written in different ways, like in this case. But when you do calculations, please do not write it in a different way other than this one. This is the one that I like. That is going to be given, not even I like, but this is the one that is going to be given in your formula sheet. And you must write it according to the one that is given in your formula sheet. F1 over A1 equals to F2 over A2, only grade 12, please. And then this part here is not necessary. You can start with it if you like, but if you don't like it, it's not necessary. You can just start with F1 over A1, right? This helps us to determine the greater force that is produced, or it can even help us to determine the force that was exerted if we know the greater force that was produced, okay? Some of the things that you need to know: area this side is small, area this side is great. Force this side is small, force this side is great or bigger, okay? These are some of the things that you must always remember when dealing with calculations that involve hydraulics, okay? Now, what are another things that you have to look for? As you can see here, the formula is talking of area. What comes back now? The calculation of areas again, grade 12. And most of the time, since these are piston, here we're going to be calculating the area of a what? Of a circle. Okay, we're going to be calculating the area of a circle here, circular area, which is going to be pi r squared. Okay, if not, pi d squared over 4. But this here, most of the time, the pistons are going to be circular pistons. But I'm not saying there will never be square or rectangular pistons. They might even be like that. So it's important to know how to calculate the area of those shapes. It comes back again. I hope you can see that. So it comes back. So it means if you are able to master that with the stress, the strain, then it means this is going to become a take-a-farmer question for you. Take and go question, where you are just going to run through it because it is using the same knowledge that you were dealing with as you were dealing with stress, strain, and Young's modulus. Then, very, very simple it should be. So please, now, what does this come with, this issue of calculating areas? Obviously, it's going to come with a conversion from millimeter to meter. It comes with a conversion from centimeter to meter. Please, great job. It comes with a conversion of millimeter squared to meter squared. It also comes with a conversion from centimeter squared to meter squared. So again, I'm stressing on these things that are stressed at the beginning of the lesson as we're doing that prior knowledge assessment there. I was stressing the issue of converting. I was stressing the issue of calculating the area. I was stressing the issue of also converting the area. Please. These are the basic things that you need to know while going to do these calculations. And of course, after this, you have to know the uses of this hydraulic system. I employ you to know at least 3. Okay? Know at least 3. And I'm going to give them to you now if you have a problem. The 3 that I want you to list. And even if everyone can name the same 3 in your final exam, I would know that you were given by me through just-in-time revision lesson. And number 1, I want you to say it's forklift. Number 1, say forklift. Number 2, I want you to say dentist chairs. Number 2, I want you to say dentist chair. And number 3, I want you to say hydraulics car jacks. Hydraulics car jacks. If you have a problem with naming others, there are a lot. I've just named these 3. You can name bulldozers. You can name hydraulic car lift. You can name hydraulics car brakes. They are a lot. But these are the 3 that I'm saying. If you are going to have a problem, know these 3. I want you to say forklift, dentist chairs, hydraulics car jacks. Have those 3 and make sure that you know them. Whenever they say give examples of hydraulic of the application of hydraulic system, then you'll be able to do that grade 12. Okay. All right. So let's quickly get an example there where we are going to do calculations related to hydraulics. The questions are going to be as simple as this. Look at the marks: 4 marks, 2 marks, 6. Okay. Don't mind the 22. It means there were other questions before these questions that I took. All right. So it says here, the diagram below shows a hydraulic lift where a force of 550 newtons, right, F1, they even tell you, is applied to a piston with an area of 0.5 square meters. The area is given in square meters. Lucky for us, no conversion needed. The area of the second piston is 1.5, as you can see, bigger than the first one. 1.5 bigger than 0.5. It is also in square meters, meaning that we do not need to do conversions. And it also means that we don't need to calculate our own for our own area. Sometimes we will give in the radius of the piston, right? The diameter of the piston. That means we have to calculate for your own area first and calculate for it in square meters. Then you can use the formula to substitute. Okay, so let's do the calculation. I will start with P1 is equals to P2 because the pressure applied at any point will be transmitted equally to the other parts of the liquid. That's what Pascal's law says. You must be able to state that law. All right, that is F1 over A1 is equals to F2 over A2. So here we are looking for the what? For F2, the output force. Here, that's what we are looking for here. We are looking for F2, which is the output force. Right, F1, we are given as 550 newtons. A1, we are also given as 0.5. Okay, this is equals to F2. We don't know what F2 is, but A2 is given as 1.5 square meters. Then what do we do from here? We just simply solve for F2. There are different ways, mathematical ways you can try, right? I prefer the cross multiplication, where this multiplies by this, right? Let's continue here. We are going to have 0.5 F2 multiplied by F2, obviously. And then we are also going to have 550 multiplied by 0.5. 1.5, sorry. 1.5. Almost made a grave mistake there, right? So 550 multiplied by 1.5. So to get our F2, divide by 0.5, divide by 0.5 on both sides. Then F2 will be given as, take your calculator, 550 multiplied by 1.5 over 0.5, right? And then it should be 1,650 newtons. And it is upwards. Remember, force is a vector, it has magnitude and direction. So it's a force that is facing upward. Okay? So this is as simple as that. They could have asked for the mass if maybe there was an object here. They say, calculate the mass M of this object, right? It's nothing new. We continue from here. Let's say there was an object here. It is being pushed up. The force that is applied is 550. Calculate the mass of this object. It's the same as the one that we did for stress first example there. It means the mass of this object would be, you can get it through the weight, where you say weight is equal to mg. Then we know the weight is 1650 is equal to m times 9.8. Then you divide by 9.8, you divide by 9.8. For those who have encountered a question like this and struggled with, this is simply how you do the question. You don't change anything, you calculate this very same way. Okay, 9.8. It means the mass that we can push with a force of 550 on this machine here is 168.37 kilograms, if they were asking for mass, right? And I hope I'm helping someone who was maybe having a challenge with this issue of mass, this calculation of mass. This is how you work with it, Creator. This is how you work through this calculation of mass. Okay, again, I emphasize, know how to state Pascal's law, right? Please know the definition also there that we talked about pressure and thrust, but know how to state Pascal's law, and then also know how to do calculation related to Pascal's law. Remember the conversions from millimeters to meters, centimeters to meters, square millimeters to square meters, square centimeters to square meters. Please, please, please. Times 10 to the power minus 3, times 10 to the power minus 2, times 10 to the power minus 6, times 10 to the power minus 4, respectively. Okay? I've shown you at the beginning of the lesson. Please, Creator. These, if you know these things, you are going to take all of these marks. Last question there was saying, give 2 uses of hydraulic system. I gave you 3 that I said you must know. So I'm expecting that each and every one of you is going to start by saying forklift, and then next you are going to say forklift, And then number 2, you are going to say dentist chairs. Okay, right? Forklift, dentist chairs. Hydraulics, car jacks, if they ask for 3, right? That is the expectation of what you are going to do. All right. Okay. Great work. We've come to the summary of the lesson here, where we are looking at the things that we have entertained or tried to learn during our lesson. Okay, so we've defined the term stress, and then we've defined the term strain. We've stated Hooke's law, and in actual fact, we've done a lot of definitions. Okay, right? This was just an idea of the definitions that we'll look at. But most importantly, we've done calculations that are relating to stress, strain, and the modulus of elasticity with their formula. Identifying the formula, doing those calculations, doing the conversions, calculations of area, all of those things. We've done that grade 12. And then we've also stated Pascal's law. And we said this is an important law for you to be able to state. And after stating Pascal's law, we've also said let's use Pascal's law to calculate the force. We've done the force, right? And we've also said you can also be asked to calculate the what? The area or radius of pistons. They can actually ask you to do that. If they give you the area of a piston, they can ask you to calculate the radius. If they give you the radius of piston, they can ask you to calculate the area. We've done that because it's as simple as calculating just the area using that formula. Excuse me, pi r squared. If not, length times breadth. If not, side squared. It's just these ones where you are calculating the area. If the radius, it is obviously going to be these ones. So you can work through all of those ones. Please know these formulas. The formula for the circle, area of a circle, the formula for area of the rectangle, the formula for the area of a what? Of a square. The formula for the area of a triangle is half base times the perpendicular height. Just in case. I doubt this will ever happen, but just in case. All right. That being said, grade 12, I will then give you homework for you to try on your own. Try answering these questions there and see if you'll be able to get them correct. Grade 12, on your own. If you struggle, you then go to your teacher for help. Try to get your teacher to help you there. But I'm sure after having this lesson, you are not going to struggle. Take note here. We are having kilonewtons here. I hope you'll be able to work through that. Right? Try this one also on hydraulics. And then if you are able to calculate that, then I know that you are home and dry in terms of getting those marks that I need you to get for your final examination grade 12. So please go over this section. Please, I am begging and asking you to go over this section. It has a lot of marks. Please make sure that you get all those marks grade 12. With that being said, grade 12, let's look at our preview for our next lesson. Our next lesson, grade 12, is going to be for the revision for our paper on the 6th of November 2025, where we'll be revising for the paper that we'll be writing the following day on the 7th of November, paper 1. So that's what we're going to be doing. And then obviously the following day we'll also revise paper 2 before you write it on the following Monday. So that's, I expect all of you to be there as we do that revision. Okay, grade 12, let us call it a day. Thank you.